The topic of our research paper is efficient management of data centers for cloud computing using energy-aware allocation methods. This review paper is presented by me, Varun, Samir, and Rishabh. So the primary issues that this review paper addresses are: first, the high cost. Information centers hosting cloud applications consume vast amount of power, causing high operational prices and carbon footprints to the surroundings. Carbon footprint. Data centers run on 50 to 60% of coal, and the price of renewable power sources are far less volatile than power derived from commodities like coal, which is useful for things like long-term budgeting and cost cutting. The problem statement of the review paper. Cloud computing offers utility-oriented IT services to users worldwide. Supported a pay-as-you-go model, it allows hosting of pervasive applications from client, scientific, and business domains. However, information centers hosting cloud applications consume vast amounts of power, causing high operational prices and carbon footprints to the surroundings. Objectives: study principles for energy efficient management of clouds, energy efficient resource allocation policies, programming algorithm considering quality of service expectations and power usage characteristics of the devices, variety of open analysis challenges addressing which might bring substantial advantage to each resource suppliers and customers. This is a model of the topic that we are presenting in the review paper.
So now let's see the abstract of a review paper. The abstract goes like this: cloud computing offers utility-oriented IT services to users worldwide, supported a pay-as-you-go model. It allows hosting of pervasive application from client, scientific, and business domains. However, information centers hosting cloud computing consume vast amount of power, causing high operational prices and carbon footprints from to the surrounding. So we propose a cloud computing solutions that may solely minimize operational prices, however conjointly cut back the environment impact. During this paper, we conduct a survey of analysis in energy efficient computing and purpose, study principles for energy efficient management of clouds, energy efficient resource allocation policies and programming algorithms considering quality of service expectations and power usage, and thirdly, variety of open analysis challenges addressing which might bring substantial advantage to each resource suppliers and customers. Now let's see the introduction. Cloud computing is a style of internet-based computing that has shared process, resource, and information to computers and different devices on demand. Cloud computing, the long-held dream of computing as a utility, has the potential to remodel and outsize a part of IT business, creating code, even a lot of insight, enticing as a service, and shaping that means IT hardware in meant and purchased. In business, these services square measure remarked as infrastructure as a service, platform as a service, and code as a service. Now let's see some of the related work. In the first paper, that is Cloud Computing and Emerging IT Platform, the author has defined cloud computing and has provided the architecture for creating cloud with market-oriented resource allocation by leveraging technologies such as virtual machines. The second paper, Energy and Performance Aware Scheduling of Tasks on Parallel and Distributed Systems. Here the author talks about large-scale systems such as computational grids consume a significant amount of energy due to their massive sizes. This and the energy and cooling costs of such systems are often comparable to the procurement cost over a year period. The third paper, resource allocation in a network-based cloud computing environment. Here the author discusses resource provisioning for cloud services in a comprehensive way are crucial to any resource allocation model. Any model should consider both computational resource and network resource to accurately represent and serve practical needs. The fourth paper title is No Power Struggles, Coordinated Multi-Level Power Management for Data Centers. In this paper, the author first studies the self-healing function, a challenging topic in today's cloud computing systems. The author focuses to fulfill the self-diagnosis and self-healing requirements of efficiency, accuracy, learning ability.
Now we will see the architecture. Clouds aim to drive the design of the next generation data centers by architecting them as networks of virtual servers so that users can access and deploy applications from anywhere in the world on demand at competitive costs depending on their QoS requirements. The following shows the high-level architecture for supporting energy-efficient services. Consumers, brokers. Cloud consumers or their brokers submit service requests from anywhere in the world to the cloud. Green Service Allocator acts as the interface between the cloud infrastructure and consumers. It requires the interaction of the following components to support energy-efficient resource management. Green Negotiator negotiates with the consumers and brokers. Service Analyzer interprets and analyzes the service requirements of a submitted request before accepting it. Hence, it needs the latest load and energy information from Virtual Manager and Energy Monitor respectively. Consumer Profiler gathers specific characteristics of consumers so that important consumers can be granted special privileges and prioritized over other consumers. Pricing decides how service requests are charged to manage the supply and demand of computing resources. Energy Monitor observes energy consumption caused by virtual machines. Service Scheduler assigns requests to virtual machines and determines resource entitlement for allocating virtual machines. Virtual Manager keeps tracks of availability of virtual machines and their resource usage. Accounting monitors the actual usage of resources by virtual machines. Virtual machines can be dynamically started and stopped on a single physical machine according to incoming requests, hence providing the flexibility of configuring various partitions of resources on the same physical machine to different requirements of service requests. Physical machines are the underlying physical computing servers that provide the hardware infrastructure for creating virtualized resources to meet service demands. In the study, we compared four papers. The first is a base paper. In this paper, the vision, challenges, and architectural elements of energy-efficient management of cloud computing environments is focused on. Another paper that we studied was about cloud computing and which provides the architecture of creating cloud with market-oriented resources by allocation, leverage technologies, and use of virtual machines. In the second paper, we studied large-scale systems such as computational grids and energy of cooling costs of such systems. The third paper that we studied discusses the allocation and scheduling algorithms, systems, and softwares for reducing power and energy dissipation of workflows. The fourth paper that we studied uh, talks about the healing function of a challenging topic in today's cloud computing systems from consequence or oriented point of view. In this study, we finally conclude that cloud computing is still as much as a research topic as it is a market offering. What is clear through the evolution of cloud computing services is that the Chief Technical Officer (CTO) is a major driving force behind cloud adoption. The major cloud technology developers continue to invest billions a year in cloud R&D. For example, in 2011, Microsoft committed 90% of its US $9 billion R&D budget to its cloud. This work this work advances cloud computing field in two ways. First, it plays a significant role in the reduction of data center energy consumption costs and thus helps to develop a strong competitive cloud computing industry. This is especially important in context of Australia, as a recent study shows that Australia is emerging as one of the preferred data center hubs among the Asia Pacific countries. Second, consumers are increasingly becoming conscious about the environment. In Australia, a recent study shows that data centers represent a large and rapidly growing energy consumption sector of the economy. These are the references that helped us in making this study possible. Thank you.